Today's lesson is on special systems of linear equations. We're going to go ahead and solve the system of linear equations. So for number 1, our system is negative 4x plus 4y equals 8, and we have y equals x plus 2. Our first step is to write the first equation, negative 4x plus 4y equals 8, in slope-intercept form. So our first step to write this in slope-intercept form is to add 4x to both sides. So now we have 4y equals 4x plus 8. Next we can go ahead and divide both sides by 4. So we get that y equals 4 divided by 4 is 1, so we just have our x. And then plus 8 divided by 4 is 2. So we have y equals x plus 2. Now let's graph our two equations. So we'll look at our first equation, and that's the one we just solved, and we'll go ahead and graph it. So what we need to worry about graphing is y equals x plus 2 that we just solved for. Our y-intercept is 2, so we'll go on the y-axis at 2 and plot our point. And then our slope is 1. We do not have any numbers in front of x, so that would be 1. So from our point, we'll go up 1 and to the right 1. And then again, we can go up 1 to the right 1. Now we can go ahead and draw the line. This would be the graph of the first equation. Now let's look at our second equation. You will notice the second equation is exactly the same as the first equation when we solved it and put it in slope-intercept form. So the line for the second equation is going to be the exact same line. When our two equations are exactly the same, the solution is infinitely many solutions. Now let's look at number 2. Once again, we're going to solve the system of linear equations. So our system is y equals negative 5x minus 2, and we have 5x plus y equals 3. The first thing we're going to do is we're going to solve the second equation and put it in slope-intercept form. So we're going to solve this equation for y. So we have 5x plus y equals 3. To put this in slope-intercept form, we need to subtract 5x on each side. And now we're going to have y equals negative 5x plus 3. So this is the second equation. Next, we need to graph both equations. So let's go back to our first equation and graph it. The y-intercept is at negative 2, so we'll go ahead and plot our point at negative 2 on the y-axis. Now you can see that our slope is at negative 5. So if we go up 5, so 1, 2, 3, 4, 5, we need to go to the left 1, and we'll plot our point. Now we can go up 5 again, 1, 2, 3, 4. You notice that we're going to be off our graph. So let's go back to the original point that we had, and let's go ahead and go down 5. That would be our negative. So 1, 2, 3, 4, 5. Since we went down, that was the negative, so we'll go to the right 1 to plot our point. So now we have the graph and the line of the first equation. Next, we need the second equation. What will we use is the part that we solved for down here at the bottom. So we have y equals negative 5x plus 3. So let's go ahead and plot our y-intercept at 3. So we'll go onto the y-axis up to 3 and plot our point. And then we'll go ahead and use our slope, which is negative 5. And from here we can go, if we go up 5, 1, 2, 3, 4, 5, you notice we're off our graph. So we'll go down 5, 1, 2, 3, 4, 5. And then we'll go to the right 1 and plot our point. We can do that again. Down 1, 2, 3, 4, 5, and to the right 1. Now we can draw the line. You notice that these two lines are parallel. If we graph two equations and the lines are parallel, that means there is no solution. Now in summary, A system of linear equations can have one solution, no solution, or infinitely many solutions. The first graph that you see is representation of one solution. The lines will intersect. The middle graph would be no solution because the lines are parallel. And the last graph would be infinitely many solutions because the lines are the same.